In lesson 6, we're going to continue learning about mirrors. However, this lesson will focus on what are known as diverging mirrors or convex mirrors. Our goals will be to draw the light ray diagrams to locate images in these new types of mirrors. Then we'll differentiate between real and virtual images, and finally describe the properties of the image using the SALT acronym. Let's get started. In the last lesson, we looked at concave mirrors. These are also referred to as converging mirrors. And this is because parallel rays of light converge at the focal point, which is just another way of saying that they go in towards the focus. And we can see an example of this in the picture to the right. Here we have two incoming rays of light. Remember, we're going to assume that light rays always go left to right. So the first one over here is moving from left to right. This is a ray of light that is parallel to the principal axis. And the rule that we learned is that when this ray of light hits the mirror, it reflects and passes through the focal point. We can see this in the picture. Similarly, there's another incoming ray of light below. This one is also parallel to the principal axis, and therefore when it hits the mirror, it reflects and passes through the focal point. So notice that this type of mirror tends to converge or bend the light towards the focal point. Convex mirrors do the opposite. These mirrors are also known as diverging mirrors. And the reason being, this type of mirror causes parallel rays of light to diverge or basically reflect away from the focus. We can see this in the picture to the right. So here's our diverging mirror to the right. Remember, we said that concave mirrors cave inward, and the convex or diverging mirrors bend away from the direction of light. So in this example, we have two incoming rays of parallel light, which I'll just highlight here in blue. Notice that they diverge away from each other. But something to take away here is that mirrors always obey the laws of reflection. So for any ray of light hitting the mirror, we're going to see the law of reflection obeyed. Alright, so in a similar way to what we did in the last lesson, we're going to look at some rules for understanding how light rays reflect when they hit a convex mirror. Let's take a look. In our first rule, whenever an incident ray of light parallel to the principal axis hits the mirror, it reflects like they came from the focal point. Let's take a look in the picture to the right. So here's our principal axis. We have an incoming ray of light going left to right. I'll just highlight that to make it clear. That's our ray of light. When it hits the mirror, it diverges when it hits the mirror, it reflects away like this. But it's going to appear like that ray of light came from the focal point on the other side of the mirror. So we can backtrace it by drawing that dotted line like so, and that would be rule number 1. Rule number 2 tells us that an incident ray of light that goes towards the focus will reflect parallel to the principal axis. It's basically just the opposite of rule number 1. Let's take a look in the picture to the right. So we have an incoming ray of light, which I'll highlight here in blue. This is our principal axis below. When this ray of light hits the mirror, it comes out parallel to the principal axis like so. Okay, notice that this ray of light was heading towards the focal point on the other side of the mirror. It's not actually going to get there though because the mirror reflects the ray of light away. Rule number 3 tells us that an incident ray of light that goes in towards the center, that's the point labeled C, will reflect back towards where it came from. Okay, so we'll take a look at this. Here's our incident ray of light. It's heading towards point C. It's not going to actually get there though because the mirror is in the way, but what it does is reflects off of the mirror and heads backwards in the same direction that it came from. And finally, for rule number 4, an incident ray of light that goes in towards the vertex. Remember, that's the point where the principal axis meets the mirror. I'll just label it with a V in the picture. That ray of light will hit the mirror, reflect on the other side with the same angle, obeying the law of reflection. Let's take a look in the picture. Here's our incoming ray of light. Imagine it hits the mirror at an angle of 30 degrees relative to the principal axis. That ray of light will reflect at the same angle like so. And if we form a virtual image, we're going to look at where the reflected ray of light appears to have come from, which I'll just continue, which I'll show by extending the dotted line behind the mirror. Let me just move the V like that. All right, so those are the 4 rules for convex mirrors. And now we're going to look at how we use these rays of light to find images. Here are 3 steps. We showed you 4 rays of light on the previous page. However, you really only need to draw any 3 of them. Then extend the reflected rays behind the mirror until they intersect. And wherever those 3 virtual rays converge will be the location of your image. Let's see how this is done in the example below. Here we go. So we have a convex mirror. Our object is represented by this arrow on the principal axis. And let's determine the location of the image. So we're allowed to draw any 3 of the previous rays. The first one that I'm going to draw is the one that is parallel to the principal axis. Here we go. So that ray of light is going to reflect away, but appear like it came from the focal point. So to help you draw this, you can draw a dotted line that goes from the location where the ray of light hit the mirror and the focal point, and just draw an extended line away like so. All right, so that's the first ray of light. The second one that I'll draw is a ray of light that passes through the focal point. Let's do that. So this ray of light leaves the object. It's trying to get to the focal point. Remember, it's trying to get there, so you can draw the extended ray of light like so. It never does get there though. It reflects and comes out parallel. However, to help us find the image, you can backtrace it. So again, backtrace it behind the mirror. And just to help you clean it up, you can get rid of this dotted line. I was just trying to make sure that that second ray of light was heading towards the focus, but that dotted line there doesn't help us find the image. And you can already see, just by drawing 2, that the image is probably going to form over here where the 2 dotted lines are crossing. But just to be sure, let's draw one more. And the third one that I'll draw is the ray of light that passes through the vertex right here. So we have a ray of light heading towards the vertex like so. It's going to obey the law of reflection and reflect at the same angle it came in at, so something like this. And remember, we extend. And remember, we extend the dotted line behind the mirror. And there we go. So the image will be at the location where they all cross. It appears to be right over here. So let me draw the image. Okay, so the red arrow is supposed to represent the image. Let's quantify this now using the SALT acronym. You can verify with a ruler, but the size of the image is in fact smaller. As for the attitude, it's upright. It forms behind the mirror. And you know that anytime something forms behind the mirror, the light appears like it's coming from a location, so that would be a virtual image. Okay, let's try the next practice question. So we're going to find the images in the mirrors below by drawing just 2 light rays. In fact, you really only need 2 when you're doing these types of questions. I mean, 2 is more than enough, but definitely the more that you include, the more accurate your location of image will be. So let's go ahead and find the location of the candle in part A by drawing 2 light rays. For me personally, one of the light rays I like to draw is the one that is parallel to the principal axis, like so. That one, remember, will reflect away from the mirror, but it appears like it's coming from the focal point. So to help me draw it, I always draw a dotted line that goes towards the focus. And then I just extend the reflected ray of light on the other side. The second one that I'm going to draw is a ray of light that passes through the focal point, like so. Remember, this ray of light is going to try and go through the focal point, but it reflects away. And this ray of light comes out parallel, like so. Okay, draw the extended ray of light behind the mirror. And wherever they cross is the location of the image. So our image will be at this location approximately. And there you go, everyone. Let's quantify it. The size is definitely smaller. As for the attitude, it is indeed upright. It's behind the mirror. And therefore, that means it is a virtual image. Okay, let's do another one in this where our object is now the Eiffel Tower. So I'll begin by drawing a ray of light that is parallel to the principal axis. But again, I like to draw that ray of light that comes from the focus point just to help me out. All right, that's one. As for the second one, I'll draw the ray of light that passes through the focal point once again, something like this. All right, that one reflects and comes out parallel. But now you backtrace it behind the mirror. And our image appears to be where the two rays of light cross on the other side. And our image appears to be where the two virtual rays of light cross on the other side. Okay, so the image is approximately here. So the size is again smaller. It's upright as well. The location is once again behind the mirror. And therefore that makes it a virtual image. So, in conclusion, from what we've seen so far, the image from a convex mirror is always smaller, upright, and virtual. And the reason why it's virtual is because it's behind the mirror, so we can add that in as well. And that's going to wrap up lesson number 6. Here's some practice for you to try for homework. Please do so, and if you have any questions, don't hesitate to reach out. Thanks everyone, we'll see you in the next video.